Welcome to the channel NextGen Tech Prep. In today's video, we are diving deep into essential questions and comprehensive answers for the Google Professional Data Engineer certification. Whether you're preparing for an exam or just looking to sharpen your knowledge, you're in the right place. If you find this content valuable, please hit that subscribe button and ring the notification bell so you never miss an update. Now, let's get started.
Your team is responsible for developing and maintaining ETLs in your company. One of your Dataflow jobs is failing because of some errors in the input data, and you need to improve reliability of the pipeline, including being able to reprocess all failing data. What should you do? The options are: Option A, add a filtering step to skip these types of errors in the future, extract erroneous rows from logs. Option B, add a try-catch block to your do-fn that transforms the data, extract erroneous rows from logs. Option C, add a try-catch block to your do-fn that transforms the data, write erroneous rows to pub/sub directly from the do-fn. Option D, add a try-catch block to your do-fn that transforms the data, use a side output to create a p collection that can be stored to pub/sub later.
To arrive at the correct answer, we focus on the keywords: Dataflow jobs is failing, errors in the input data, reprocess all failing data.
The correct answer is option D, add a try-catch block to your do-fn that transforms the data, use a side output to create a p collection that can be stored to pub/sub later.
Why is this correct? D. Using a try-catch block to handle errors and routing erroneous records to a side output, dead letter queue pattern, is the standard and most reliable way in Apache Beam to capture and reprocess failed data. Why are the others incorrect? A. Extracting erroneous rows from logs is unreliable, unscalable, and makes reprocessing difficult, as logs are not designed for data storage and retrieval. B. Like option A, extracting data from logs is not a robust or scalable method for data recovery and reprocessing. C. Writing directly to an external sink, pub/sub, from within a do-fn is an anti-pattern. It bypasses Beam's guarantees, potentially causing duplicate records during retries.
You're training a model to predict housing prices based on an available dataset with real estate properties. Your plan is to train a fully connected neural net, and you've discovered that the dataset contains latitude and longitude of the property. Real estate professionals have told you that the location of the property is highly influential on price, so you'd like to engineer a feature that incorporates this physical dependency. What should you do? The options are: Option A, provide latitude and longitude as input vectors to your neural net. Option B, create a numeric column from a feature cross of latitude and longitude. Option C, create a feature cross of latitude and longitude, bucketize it at the minute level and use L1 regularization during optimization. Option D, create a feature cross of latitude and longitude, bucketize it at the minute level and use L2 regularization during optimization.
To arrive at the correct answer, we focus on the keywords: fully connected neural net, latitude and longitude, location of the property is highly influential on price, engineer a feature.
The correct answer is option C, create a feature cross of latitude and longitude, bucketize it at the minute level and use L1 regularization during optimization.
Why is this correct? C. Bucketizing and crossing latitude and longitude creates a categorical grid capturing nonlinear spatial dependencies. L1 regularization induces sparsity, efficiently zeroing out weights for grid cells with no properties, improving model performance. Why are the others incorrect? A. Passing raw latitude and longitude assumes a simple relationship, ignoring the highly nonlinear, complex dependency of real estate prices on specific physical locations. B. Feature crosses are meant for categorical features, not continuous numerical columns like raw latitude and longitude. Bucketization is required first to discretize them. D. L2 regularization shrinks weights but does not yield a sparse model. For a massive grid of bucketized locations where many cells are empty, L1 is strictly better to zero out irrelevant features.
You are deploying MariaDB SQL databases on GCE VM instances and need to configure monitoring and alerting. You want to collect metrics including network connections, disk I/O, and replication status from MariaDB with minimal development effort and use Stackdriver for dashboards and alerts. What should you do? The options are: Option A, install the Open Census agent and create a custom metric collection application with a Stackdriver exporter. Option B, place the MariaDB instances in an instance group with a health check. Option C, install the Stackdriver logging agent and configure Fluent in_tail plugin to read MariaDB logs. Option D, install the Stackdriver agent and configure the MySQL plugin.
To arrive at the correct answer, we focus on the keywords MariaDB, collect metrics, minimal development effort, Stackdriver.
The correct answer is option D, install the Stackdriver agent and configure the MySQL plugin.
Why is this correct? D. The Stackdriver agent, cloud monitoring agent, includes a MySQL plugin that natively supports MariaDB, allowing for metric collection such as network connections and replication status with minimal development effort. Why are the others incorrect? A. Creating a custom metric collection application with Open Census requires significant development effort, violating the requirement for minimal development effort. B. Health checks monitor instance availability but do not collect detailed internal metrics like disk I/O or replication status from the database. C. The Stackdriver logging agent is used to collect logs, not specific metrics like network connections, disk I/O, or replication status.
You work for a bank. You have a labeled dataset that contains information on already granted loan application and whether these applications have been defaulted. You have been asked to train a model to predict default rates for credit applicants. What should you do? The options are: Option A, increase the size of the dataset by collecting additional data. Option B, train a linear regression to predict a credit default risk score. Option C, remove the bias from the data and collect applications that have been declined loans. Option D, match loan applicants with their social profiles to enable feature engineering.
To arrive at the correct answer, we focus on the keywords labeled dataset, already granted loan application, predict default rates.
The correct answer is option B, train a linear regression to predict a credit default risk score.
Why is this correct? B. Training a linear regression model is an appropriate approach for predicting a continuous numerical outcome, such as a credit default risk score or rate, using the available features. Why are the others incorrect? A. Collecting additional data is unnecessary before establishing a baseline model and evaluating its performance on the currently available labeled dataset. C. Declined loan applications cannot provide valid labeled data for this specific task, as it is impossible to know whether those ungranted loans would have defaulted. D. Matching social profiles introduces significant privacy, ethical, and compliance risks, and is not a standard or required practice for basic credit risk modeling.
You need to migrate a 2 terabytes relational database to Google Cloud Platform. You do not have the resources to significantly refactor the application that uses this database, and cost to operate is of primary concern. Which service do you select for storing and serving your data? The options are: Option A, Cloud Spanner. Option B, Cloud Bigtable. Option C, Cloud Firestore. Option D, Cloud SQL.
To arrive at the correct answer, we focus on the keywords 2 terabytes relational database, do not have the resources to significantly refactor the application, cost to operate is of primary concern.
The correct answer is option D, Cloud SQL.
Why is this correct? D. Cloud SQL is a managed relational database that easily supports 2 terabytes workloads. It requires minimal application refactoring since it uses standard relational engines, and it is the most cost-effective option for this scenario. Why are the others incorrect? A. Cloud Spanner is a globally distributed relational database. While it supports relational data, it is significantly more expensive than Cloud SQL and is unnecessary for a 2 TB workload. B. Cloud Bigtable is a NoSQL wide column store. Migrating a relational database to a NoSQL database would require significant application refactoring, which is not an option. C. Cloud Firestore is a NoSQL document database. Moving from a relational database to Firestore requires extensive application refactoring, violating the constraint.
You're using Bigtable for a real-time application, and you have a heavy load that is a mix of read and writes. You've recently identified an additional use case and need to perform hourly an analytical job to calculate certain statistics across the whole database. You need to ensure both the reliability of your production application as well as the analytical workload. What should you do? The options are: Option A, export Bigtable dump to GCS and run your analytical job on top of the exported files. Option B, add a second cluster to an existing instance with a multi-cluster routing. Use Live Traffic App Profile for your regular workload and Batch Analytics Profile for the analytics workload. Option C, add a second cluster to an existing instance with a single cluster routing. Use Live Traffic App Profile for your regular workload and Batch Analytics Profile for the analytics workload. Option D, increase the size of your existing cluster twice and execute your analytics workload on your new resized cluster.
To arrive at the correct answer, we focus on the keywords: Bigtable, real-time application, mix of read and writes, hourly and analytical job. Ensure both the reliability of your production application as well as the analytical workload.
The correct answer is option C. Add a second cluster to an existing instance with a single cluster routing. Use Live Traffic App Profile for your regular workload and Batch Analytics Profile for the analytics workload.
Why is this correct? C. Adding a second cluster with single cluster routing allows isolating workloads. The production application routes to one cluster, while the batch analytics route to the other, ensuring heavy analytical queries don't impact real-time performance. Why are the others incorrect? A. Exporting a Bigtable dump to GCS hourly is inefficient, introduces latency, and fails to utilize Bigtable's native workload isolation capabilities via replication and app profiles. B. Multi-cluster routing automatically routes requests to the nearest available cluster, preventing guaranteed workload isolation. Analytical queries could be routed to the production cluster, impacting real-time performance. D. Simply increasing cluster size adds capacity but lacks workload isolation. Heavy analytical scans running on the same nodes as production traffic can still cause resource contention and latency spikes.
You are designing an Apache Beam pipeline to enrich data from Cloud Pub/Sub with static reference data from BigQuery. The reference data is small enough to fit in memory on a single worker. The pipeline should write enriched results to BigQuery for analysis. Which job type and transforms should this pipeline use? The options are: Option A, batch job, pub/sub.io, side inputs. Option B, streaming job, pub/sub.io, JDBC.io, side outputs. Option C, streaming job, pub/sub.io, BigQuery.io, side inputs. Option D, streaming job, pub/sub.io, BigQuery.io, side outputs.
To arrive at the correct answer, we focus on the keywords: Cloud Pub/Sub, static reference data from BigQuery, small enough to fit in memory, write enriched results to BigQuery.
The correct answer is option C, streaming job, pub/sub.io, BigQuery.io, side inputs.
Why is this correct? C. Cloud Pub/Sub provides unbounded data, requiring a streaming job. BigQuery.io is used to read and write BigQuery data, and side inputs are ideal for joining small in-memory reference data. Why are the others incorrect? A. Cloud Pub/Sub provides unbounded data, which requires a streaming job rather than a batch job. B. BigQuery.io should be used instead of JDBC.io to interact with BigQuery natively. Additionally, side outputs are used to branch data streams, not load reference data. D. Side outputs are used to emit data to multiple output branches. To bring external reference data into a transform for enrichment, side inputs must be used instead.
You have a data pipeline that writes data to Cloud Bigtable using well-designed row keys. You want to monitor your pipeline to determine when to increase the size of your Cloud Bigtable cluster. Which two actions can you take to accomplish this? Choose two. The options are: Option A, Review Key Visualizer Metrics. Increase the size of the Cloud Bigtable cluster when the read pressure index is above 100. Option B, Review Key Visualizer Metrics. Increase the size of the Cloud Bigtable cluster when the write pressure index is above 100. Option C, Monitor the latency of write operations. Increase the size of the Cloud Bigtable cluster when there is a sustained increase in write latency. Option D, Monitor storage utilization. Increase the size of the Cloud Bigtable cluster when utilization increases above 70% of max capacity. Option E, Monitor latency of read operations. Increase the size of the Cloud Bigtable cluster of read operations take longer than 100 milliseconds.
To arrive at the correct answer, we focus on the keywords: writes data, Cloud Bigtable, monitor your pipeline, determine when to increase the size, Cloud Bigtable cluster.
The correct answers are option C, monitor the latency of write operations. Increase the size of the Cloud Bigtable cluster when there is a sustained increase in write latency. And option D, monitor storage utilization. Increase the size of the Cloud Bigtable cluster when utilization increases above 70% of max capacity.
Why is this correct? C. A sustained increase in write latency indicates the cluster lacks sufficient CPU resources to handle the write load. Increasing node count provides more processing power to reduce latency. D. Google recommends keeping storage utilization below 70% per node for optimal performance. Scaling the cluster adds nodes, distributing the data and keeping storage per node below this recommended limit. Why are the others incorrect? A. Key Visualizer helps identify row key hotspots or unbalanced workloads, not general cluster under-provisioning. The read pressure index indicates read hotspots rather than a direct need to scale the entire cluster. B. Key Visualizer is used for debugging row key designs and hotspots, not for making generic scaling decisions based on overall load. High write pressure indicates a hotspot, not insufficient cluster capacity. Why are the others incorrect? E. The prompt specifies the pipeline writes data, making read latency less relevant to monitoring this specific workload. Additionally, an arbitrary hard threshold of 100 milliseconds is not a standard scaling trigger.
You want to analyze hundreds of thousands of social media posts daily at the lowest cost and with the fewest steps. You have the following requirements. You will batch load the posts once per day and run them through the Cloud Natural Language API, will extract topics and sentiment from the posts, must store the raw posts for archiving and reprocessing, will create dashboards to be shared with people both inside and outside your organization. You need to store both the data extracted from the API to perform analysis as well as the raw social media posts for historical archiving. What should you do? The options are: Option A, store the social media posts and the data extracted from the API in BigQuery. Option B, store the social media posts and the data extracted from the API in Cloud SQL. Option C, store the raw social media posts in cloud storage and write the data extracted from the API into BigQuery. Option D, feed to social media posts into the API directly from the source, and write the extracted data from the API into BigQuery.
To arrive at the correct answer, we focus on the keywords: lowest cost, fewest steps, store the raw posts for archiving, perform analysis, historical archiving.
Correct answer is option C, store the raw social media posts in cloud storage, and write the data extracted from the API into BigQuery.
Why is this correct? C. Cloud storage is the most cost-effective option for archiving raw, unstructured data. BigQuery is the ideal data warehouse for storing structured data extracted from the API to perform analysis and build dashboards. Why are the others incorrect? A. Storing raw, unstructured text data in BigQuery is not cost-effective or optimal for historical archiving compared to cloud storage. B. Cloud SQL is a relational database designed for OLTP workloads, making it unsuitable and not cost-effective for large-scale archiving and analytics. D. Feeding posts directly into the API without storing them violates the requirement to store the raw social media posts for archiving and reprocessing.
You store historic data in cloud storage. You need to perform analytics on the historic data. You want to use a solution to detect invalid data entries and perform data transformations that will not require programming or knowledge of SQL. What should you do? The options are: Option A, use Cloud Dataflow with Beam to detect errors and perform transformations. Option B, use Cloud Data Prep with recipes to detect errors and perform transformations. Option C, use Cloud Data Proc with a Hadoop job to detect errors and perform transformations. Option D, use federated tables in BigQuery with queries to detect errors and perform transformations.
To arrive at the correct answer, we focus on the keywords: detect invalid data entries, perform data transformations, will not require programming or knowledge of SQL.
Correct answer is option B, use Cloud Data Prep with recipes to detect errors and perform transformations.
Why is this correct? B. Cloud Data Prep is a visual data preparation tool that allows users to clean and transform data using a UI-based recipe system. It perfectly fits the requirement as it requires no programming or SQL knowledge. Why are the others incorrect? A. Cloud Dataflow with Apache Beam requires writing programming code in languages like Java, Python, or Go, which contradicts the requirements. C. Cloud Data Proc running Hadoop jobs requires programming skills to write data processing applications, which violates the no programming requirement. D. Using federated tables in BigQuery requires writing and executing SQL queries, directly violating the requirement of no SQL knowledge.
Your company needs to upload their historic data to cloud storage. The security rules don't allow access from external IPs to their on-premises resources. After an initial upload, they will add new data from existing on-premises applications every day. What should they do? The options are: Option A, execute sudo rsync from the on-premises servers. Option B, use Dataflow and write the data to cloud storage. Option C, write a job template in Dataproc to perform the data transfer. Option D, install an FTP server on a Compute Engine VM to receive the files and move them to cloud storage.
To arrive at the correct answer, we focus on the keywords: upload their historic data to cloud storage, don't allow access from external IPs to their on-premises resources, add new data from existing on-premises applications every day.
Correct answer is option A, execute sudo rsync from the on-premises servers.
Why is this correct? A. Executing sudo rsync from the on-premises servers pushes data directly to cloud storage. This avoids the external IP access restriction and efficiently handles both the initial upload and daily incremental additions. Why are the others incorrect? B. Dataflow is meant for data processing, not simple file transfers. Running it on GCP to pull data is blocked by the external IP access restriction. C. Dataproc is designed for Hadoop/Spark processing workloads, not for daily file transfers, and would also fail due to the external IP access restriction. D. Setting up an FTP server on a Compute Engine VM adds unnecessary infrastructure, security risks, and maintenance overhead when sudo can directly push to cloud storage.
You have a query that filters a BigQuery table using a where clause on timestamp and ID columns. By using BigQuery dry_run, you learn that the query triggers a full scan of the table, even though the filter on timestamp and ID select a tiny fraction of the overall data. You want to reduce the amount of data scanned by BigQuery with minimal changes to existing SQL queries. What should you do? The options are: Option A, create a separate table for each ID. Option B, use the limit keyword to reduce the number of rows returned. Option C, recreate the table with a partitioning column and clustering column. Option D, use the BigQuery maximum_bytes_build flag to restrict the number of bytes build.
To arrive at the correct answer, we focus on the keywords, where clause on timestamp and ID columns, triggers a full scan of the table, reduce the amount of data scanned, minimal changes to existing SQL queries.
The correct answer is option C, recreate the table with a partitioning column and clustering column.
Why is this correct? C. Partitioning on the timestamp and clustering on the ID allows BigQuery to prune partitions and skip data blocks, significantly reducing the amount of data scanned without requiring any changes to existing SQL queries. Why are the others incorrect? A. Creating a separate table for each ID significantly increases management overhead and requires modifying existing SQL queries to reference the new sharded tables. B. The limit keyword only restricts the number of rows returned in the final result set. It does not reduce the total amount of data scanned by BigQuery during query execution. D. The maximum_bytes_build flag simply causes the query to fail if it exceeds the specified cost threshold. It does not optimize the query or reduce the actual amount of data scanned.
You have a requirement to insert minute resolution data from 50,000 sensors into a BigQuery table. You expect significant growth in data volume and need the data to be available within 1 minute of ingestion for real-time analysis of aggregated trends. What should you do? The options are: Option A, use BigQload to load a batch of sensor data every 60 seconds. Option B, use a cloud Dataflow pipeline to stream data into the BigQuery table. Option C, use the insert statement to insert a batch of data every 60 seconds. Option D, use the merge statement to apply updates in batch every 60 seconds.
To arrive at the correct answer, we focus on the keywords, significant growth in data volume, within 1 minute of ingestion, real-time analysis.
The correct answer is option B, use a cloud Dataflow pipeline to stream data into the BigQuery table.
Why is this correct? B. Cloud Dataflow provides a robust, scalable pipeline to stream high-volume sensor data directly into BigQuery, meeting the requirement for data availability within 1 minute for real-time analysis. Why are the others incorrect? A. BigQload is designed for batch processing and is subject to strict daily quota limits per table, making it unsuitable for continuous execution every 60 seconds. C. BigQuery DML insert statements are subject to strict concurrency and quota limits, making them inappropriate for high-frequency streaming ingestion every minute. D. The merge statement is designed for complex, infrequent batch updates and upserts, not for continuous, high-frequency appending of new sensor data.
You need to copy millions of sensitive patient records from a relational database to BigQuery. The total size of the database is 10 terabytes. You need to design a solution that is secure and time-efficient. What should you do? The options are: Option A, export the records from the database as an Avro file. Upload the file to GCS using SUDL, and then load the Avro file into BigQuery using the BigQuery web UI in the GCP console. Option B, export the records from the database as an Avro file. Copy the file onto a transfer appliance and send it to Google, and then load the Avro file into BigQuery using the BigQuery web UI in the GCP console. Option C, export the records from the database into a CSV file. Create a public URL for the CSV file, and then use Storage Transfer Service to move the file to cloud storage. Load the CSV file into BigQuery using the BigQuery web UI in the GCP console. Option D, export the records from the database as an Avro file. Create a public URL for the Avro file, and then use Storage Transfer Service to move the file to cloud storage. Load the Avro file into BigQuery using the BigQuery web UI in the GCP console.
To arrive at the correct answer, we focus on the keywords, sensitive patient records, 10 terabytes, secure and time efficient.
The correct answer is option A. Export the records from the database as an Avro file. Upload the file to GCS using SUDL, and then load the Avro file into BigQuery using the BigQuery web UI in the GCP console.
Why is this correct? A. Avro is the optimal format for BigQuery. Using SUDL is secure and time efficient for 10 terabytes, as direct network transfer is much faster than the physical shipping delays associated with a transfer appliance. Why are the others incorrect? B. Shipping a transfer appliance for only 10 terabytes introduces significant physical transit delays, failing the time-efficient requirement. C. Creating a public URL exposes sensitive patient records to the internet, completely violating the strict security requirement. CSV is also less efficient than Avro. D. Creating a public URL exposes sensitive patient records to the internet, completely violating the strict security requirement.
You need to create a near real-time inventory dashboard that reads the main inventory tables in your BigQuery data warehouse. Historical inventory data is stored as inventory balances by item and location. You have several thousand updates to inventory every hour. You want to maximize performance of the dashboard and ensure that the data is accurate. What should you do? The options are: Option A, leverage BigQuery update statements to update the inventory balances as they are changing. Option B, partition the inventory balance table by item to reduce the amount of data scanned with each inventory update. Option C, use the BigQuery streaming the stream changes into a daily inventory movement table. Calculate balances in a view that joins it to the historical inventory balance table. Update the inventory balance table nightly. Option D, use the BigQuery bulk loader to batch load inventory changes into a daily inventory movement table. Calculate balances in a view that joins it to the historical inventory balance table. Update the inventory balance table nightly.
To arrive at the correct answer, we focus on the keywords, near real-time inventory dashboard, BigQuery data warehouse, several thousand updates to inventory every hour, maximize performance.
The correct answer is option C. Use the BigQuery streaming the stream changes into a daily inventory movement table. Calculate balances in a view that joins it to the historical inventory balance table. Update the inventory balance table nightly.
Why is this correct? C. The BigQuery streaming API handles high-frequency, near real-time data ingestion efficiently. Calculating balances via a view that joins daily movements with historical balances ensures accuracy while maximizing performance and avoiding quota limits. Why are the others incorrect? A. BigQuery is an OLAP database, not OLTP. Executing several thousand update statements per hour is highly inefficient, anti-pattern, and will exceed DML quota limitations. B. Partitioning by item, high cardinality, is not ideal. Moreover, partitioning does not resolve the performance and quota issues caused by thousands of frequent row-level updates in BigQuery. D. The BigQuery bulk loader is designed for batch ingestion, which introduces latency and fails to satisfy the requirement for a near real-time inventory dashboard.